Now I hand over, so please give him a hand. Thanks. The next speaker is Roberto, and he presents ATSI, Augmented and Tangible Sony Interaction.
Yeah. Can I have sound as well? From this? Wait. But it should come from here.
Right. I know. We're controlling it.
Okay. So let's try again. So hi everybody, my name is Roberto Pugliese. I'm a PhD student from Aalto University in Finland, the Department of Computer Science. And today I'd like to introduce to new system we are developing, which is called ATSI. And ATSI stands for Augmented and Tangible Sonic Interaction. But as I like to call it, it's about put a sound on it. So let me show you what this system does. Let's hope we have sound. And there is no sound.
Birch canoe slid on the smooth plank.
Okay, wait a moment. And try again.
The birch canoe slid on the smooth planks. The birch canoe slid on the smooth planks.
The birch canoe slid on the smooth planks. The birch canoe slid on the smooth planks.
The birch canoe slid on the smooth planks. Slid on the smooth planks. The birch canoe 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 slid on the smooth planks.
So what is ATSI? ATSI is a system that lets you attach virtual sound to physical objects present in the room using gestures. And so the sound reproduction happens through headphones, so it's like binaural reproduction. And the main point is that we don't want the object to be custom, and we don't want to put sensor in it, we don't want to put markers. And the idea is that you can hear the sound spatially as if it was coming from the object. So you can get close to the object, far from the object, and you keep always this first person's perspective when you explore the room like sonically. And also we want to strengthen the metaphor that moving the object is moving the sound. So the two things become one. So a little bit about the context of this system. So we of course borrowed elements from augmented audio reality. So we want to extend the physical environment with virtual auditory cues and sound information for different kinds of application. We want spatial interaction, which means that this is also called like a 3D user interface, or anyway an interface that it's distributed in the real environment. And of course, we want tangible interaction because we're here. So we want to, the idea is to augment the real physical world by coupling digital information to everyday physical object and environments. All these sum together give us ATSI. So inspiration for this work, of course, borrows very much from augmented audio reality and the sort of the tech of that word. But as a concept, we can go back in time and think about music bottles, where that probably most of you already know, so I'm not going to spend time on that. But more recently, we have seen other like 3D user interface that allow sonic exploration, and also they use this metaphor of catching the sound and moving the sound, manipulating the sound like in air. So for instance, in Kai 12, this ANE system, it's an interesting system. So what it does, you wear like a gloves, it has an actuator in it, and also like there is Kinect tracking the position of the hand of the user. And basically with simple gesture, you can catch virtual sound that are in air and you can reposition them. And then there is a sound diffusion through speakers. So the main difference with this system is that we are not using any wearable in our system. We are, besides, of course, the headphones. And we want to keep this first-person perspective. So like the sound comes effectively from where you have positioned the object. Also in this application, the sounds are just virtual. They're just flying like around, and they are not connected to any physical object. More recently, last year in Kai 14, another system was presented that allows spatial sound plus semi-tangible interaction with sound, which is called Boom Room. This is an interesting system. It's quite close to ours, but the main difference is that it relies on a very expensive distribution of loudspeaker, like 56 loudspeakers, and also a off-the-shelf tracking system, so a special tracking system that allows to recognize different gestures. We don't want that, so we implemented different kinds of system. So ATSI is composed by these different modules. The first module, of course, is the tracking part, which is done with a combination of Kinect for tracking the position of the head and the position of the hand. When I'm saying tracking here, I'm talking just translation. Then on top of the headphones, we also put this called 9 degrees of freedom, orientation tracker, which basically is the orientation of the head. And with these two information, what we can say is basically we know where the user is facing and where it is in the room, and also the position of the hands. Then all this goes into a module that fuses together all this information and passes that to the audio rendering module. So for each object, the sound is correctly rendered and spatialized according to the perspective of the user. So for the sound rendering part, I don't get into the detail of the sound rendering technique, but as I said, the important thing is just that we take this information together so we know where is the sound with respect to the head of the user. And as a result, this is the kind of first-person perspective we get. Of course, it's a little bit hard to imagine now with figures, but so on top of using HRTF to simulate the spatialization, also we give some distance cues using the gain of the sound, and also using a reverb that is connected to each of the sound objects, so to give the impression that the object is further away or it's closer. In terms of sound design, what we wanted is that we want the user to be able to associate a sound that she has in the library, or she maybe downloaded, or whatever, a sound that is memorable to an object that exists in the room. So to create this association that makes sense to them. So from the point of view of the sound design, what we would like is that we can, of course, be able to just play back the sound as it is when it's connected to the object. But we also want to provide the user with some sort of manipulation. So we decided to go for granular synthesis. I don't know if you are familiar with it, but basically it allows just normal playback of the sound, but also allows to do simple time stretching, so make the sound longer or shorter without affecting the pitch. So the idea is that you can retain the characteristic of the sound that you decided to attach to the object, so that the association is still memorable. So this is a one module associated to. So this is a pepper grinder, and you can manipulate the speed of the playback speed without changing the pitch, with very characteristic of like granular resampling. And of course, you can slow it down. And of course, you can push it a little bit to the limit, so you can start to introduce artifacts and get a bit more creative. And then you can, like, of course, loop it in shorter, and also you can sort of freeze the sound and create this cloud of sound. And when you start pitching the sound, you can get a bit more creative and start layering different textures of sound. Of course, you can decide which kind of loops you want to use, if you want something that is connected to the object or something more musical. So how do you interact with the system? You do it in two phases. So when you enter in the room, there are a lot of objects. You have some sounds in your mind. You want probably to associate those, but there is no connection yet between this object and the sound. So the first part of the first phase of the interaction is actually the initialization. So we want to provide the user to go through the library and just designate an object in the room and attach the sound to it. So this is what happens. There is like a voice that just previews one of the sound, and it asks the user to attach it to an object. In this case, this coffee maker. Oops, sorry.
Sound 2.
So you can preview the sound, and it's rendered from your
Object waiting to be initialized.
Now the user does this sequence of gesture, like this
correctly
two-hands interaction.
Initialization phase completed.
And at this point, the system knows that which sound is attached to which object and where the object is. And you can, of course, repeat like this for many objects. Okay. So I speed up a bit. So when it comes to sonic interaction, what we want to do is explore the environment, listen to the sound, and be able to select the object and reposition it somewhere else. And so that moving the object is moving the sound.
In the interaction phase, the user can move in the physical space and hear the sonically augmented object.
A birch canoe slid on the smooth planks. A birch canoe slid on the smooth planks.
In order to engage with the object, the user's hand needs to be within a maximum distance from the object. When inside this interaction volume, the user will hear the sound of fire.
The birch canoe slid on the smooth planks. The birch canoe slid on the smooth planks. The birch canoe slid on the smooth planks.
The state of the object will change to selected. The user places the other hand on the object while hearing the sound of ice on fire. When the fire sounds extinguished, the user can remove the second hand and they will hear an unlocking sound. The object is now ready to be moved. After repositioning it somewhere else in the environment, the user places again the second hand on the object until the ice on fire sound vanishes. Then he removes the second hand from the object to release it.
So I skip now this, like the state transition diagram, but we try to associate some auditory icons that would be a bit like memorable, that the user could remember. And of course, the reason we have to use this two-hands interaction is because we don't have means of like knowing that the user is actually picking the object otherwise. So this application scenario we are thinking of course, comes a bit from augmented audio reality, so like some sort of soundscape preview for urban planning, so where you position those different tokens and you just explore the environment. Some sort of sonic interior design, so you could decorate your room like sonically, putting different sound to different, like attaching to different objects in the room. And some sort of music performance, so think for instance about all kinds of instruments nowadays we play that are not acoustic, but we would like to play them together, and we would like to have the impression that the sound comes actually from the instrument. So here there is an iPad a MIDI keyboard that doesn't make any sound, like a drum machine that would need an amplifier anyway. So we could send all this signal to the ATSI system and then be able to re-render those sounds from the perspective of all the musicians. So making the experience a bit more natural. And then in terms of auditory information displays, you can just attach auditory sticky notes to different objects. So for example, you could do this.
What is the plan? What is the plan?
So you could use this gesture, just tapping your head to start recording
What
a
is the
message
plan?
and attaching it to
What is the plan?
a plant. So to conclude, I showed you ATSI, a system that lets you freely and dynamically associate sound to real object, uses gestures, it doesn't need markers, and it's implemented with off-the-shelf hardware. And our goal was to provide the first-person sonic exploration of the environment using headphones reproduction. And we wanted also to provide physical spatialization manipulation of the sound. In the future, we intend to improve the initialization phase, maybe using gesture to scrub through your library and attach the sound, and using further gesture for the manipulation of the sound, as I showed you with the granular synthesis, in that we are trying Kinect 2 because it gives us more information about the orientation of the hand to a certain extent. And of course, we need to think about what happens when the system is off and somebody passes by and moves the object, and basically just leaving a ghost sound where that object was. So this could be fun as treasure hunting, but maybe not desirable in other applications. And that's it. Thanks.
Thanks, Roberto. I think we have time for 1 or 2 questions. Is there any? Or I have a question: how scalable would the system be? So probably we have, if we add to any object sounds in our environment, probably the space will become really loud. And we, did you think about how to deal with that?
Yes. Well, basically, we have this parameter that is like the distance, how the sound decays. So depending on the application, that's a parameter that you need to set, because sometimes it doesn't make sense to actually do it in a realistic physical way, because otherwise you would hear all the sound all the time. That could be desirable for a music application, but not necessarily for other kinds. So that's a parameter we can play with, and it wouldn't scale up. Now, it wouldn't be bigger than a room because Kinect wouldn't allow us to track more than that. So we can scale it down, but not scale it larger than that.
Okay, good. So thanks, Roberto. And then I